If you've taken a physics course before, you've seen these four equations. They're called the kinematic equations, and they describe the motion of an object traveling in one dimension with a constant acceleration. So in this video, we're going to use two simpler, more intuitive relationships that will actually lead us back to these equations. The first simple relationship we're going to use is the definition of velocity. So we know that velocity equals the change in distance divided by the change in time. Right? This is the definition of a derivative. So we get that dx dt is equal to the velocity. And the second relationship that we're going to use is the definition of acceleration. So we have acceleration, it's similar to velocity, but the change in velocity divided by the change in time is equal to the acceleration. dv dt equals acceleration. So how do we take these two more basic relationships and turn them into these useful equations that we know and love? Well, first of all, I've written this definition of acceleration in green for a reason, and that's because this kinematic equation here that's also written in green is actually just the definition of acceleration. And so we've already gotten our first kinematic equation. It's just the definition of acceleration. And I've forgotten my subscript 0 here to specify that this is the initial value of the velocity. So now that we have our first kinematic equation, let's work on getting our second. And the second one we'll go for is this one written in yellow here that deals with the position as well. So to get this, I'm going to rewrite this equation here, but use the definition of velocity. Instead of v, I'm going to write dx dt equals v naught plus acceleration times time. Now to solve this for the position, we're going to need to integrate with respect to time. For our limits, we'll put t naught to t. And this is our kinematic equation that we wrote in yellow to begin with, right up here. So we've actually reproduced two of our kinematic equations. And now, actually, I'll go back up here. So now that we have these two, let's try to get this equation so that we have a useful equation for when we don't want to know, or we don't need to know the acceleration. To do that, we'll take our definition of acceleration, we'll solve it for acceleration, and then we'll substitute that value, or that expression for acceleration, into this equation, and then hopefully this will pop out. So let's try that. So here's our third kinematic equation. And now let's think about what we have to do to get our fourth kinematic equation. So we have these three. What do we want to do to get the fourth? Well, we're trying to eliminate this t, right? This equation doesn't have a time term in it. So we need to find some way of taking what we already know and eliminating t. And it might not surprise you that the way I'm going to do this is I'm going to go back to this definition of acceleration. I'm going to solve it for t, and I'm going to plug it in here so we can get rid of this t term and hopefully get something that looks like this. And this is our fourth kinematic equation. And so now we've reproduced these four kinematic equations just from these two simple relationships. Now let's think about what the advantage of these two simple relationships are, just using these. Well, first of all, they're much easier to remember since it's how we're used to thinking about this. And similarly for acceleration. And another advantage of this is that to get these equations, we used a specific coordinate system where our initial position and our initial time were 0. And we also assumed that our acceleration was a constant. But you can apply these equations to any coordinate system, and even in situations when the acceleration isn't constant. So basically, they're easier to remember, and they're useful in more situations. They're more general. So this video really had two purposes. First, it was to show you that these equations that you probably used before, show you where they come from. The other purpose was to show an example of the main goal of physics. And the main goal of physics, or really any science, is to come up with the simplest relationships that we can use to describe the world we live in. So hopefully you've enjoyed this video a little bit, and I'll see you soon.